This is SpaceTime Series 25, Episode 9, for broadcast on the 21st of January 2022. Coming up on SpaceTime, the volcanic history of the red planet's Jezero Crater, NASA's Mars InSight lander placed into safe mode, and exploring the frozen wastes of the Martian North Pole. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
New observations by NASA's Mars Perseverance rover suggest that the South Séítah bedrock it's been rolling over for the past few months was most likely formed from red-hot magma. The discovery has implications for understanding and accurately dating critical events in the history of Jezero Crater. Scientists have also concluded that the rocks in the crater have interacted with water multiple times over the eons and that some contain organic molecules. The findings are being presented at a meeting of the American Geophysical Union in New Orleans. The multi-mission Mars sample return campaign begins with Perseverance. It's collecting Martian rock samples in search of evidence of ancient microbial life. Perseverance has a cache of 43 sample tubes. 6 of them have now been filled and sealed. 4 contain rock cores. 1 has a sample of the Martian atmosphere, and the other is a sort of control designed to observe any contamination the rover might have brought with it from Earth. The cache of samples will eventually be collected by a joint NASA-ESA sample return mission, expected to be launched in the 2030s, to collect the samples and return them back to Earth for more detailed study by scientists in more fully equipped laboratories. Even before the car-sized 6-wheeled Perseverance rover touched down in the red planet's Jezero Crater back in February last year, the mission's science team at NASA's Jet Propulsion Laboratory in Pasadena, California, had been wondering about the origin of the rocks in the area. Were they sedimentary, the compressed accumulation of mineral particles possibly carried to the location by the ancient river system flowing into the crater's dried-up delta? Or were they igneous, possibly born in lava flows rising to the surface from a now long extinct Martian volcano? Analysis by the laboratory aboard Perseverance identified crystals within the rock which told astronomers that what they were looking at was volcanic. A drill at the end of Perseverance's robotic arm can abrade or grind rock surfaces, allowing other instruments such as PIXL, planetary instrument for X-ray lithochemistry, to study them. PIXL uses X-ray fluorescence to map the elemental composition of the rocks. It analysed the South Séítah rock from a core sample using the rover's drill. The PIXL data showed the rock, nicknamed Brack, was composed of an unusual abundance of large olivine crystals engulfed in pyroxene crystals. And that indicates the rock formed when crystals grew and settled in a slowly cooling magma, such as a thick lava flow, lava lake or magma chamber. The rock was then altered by water several times, making it a treasure trove that will allow future scientists to date events in Jezero, better understand the period in which water was more common on the surface of Mars, and reveal the early history of the planet. Still to be determined is whether the olivine-rich rock formed in a thick lava lake cooling on the surface, or whether it was in a subterranean chamber that was later exposed by erosion. Also great news for the Mars Sample Return Project is the discovery of organic compounds by SHERLOC, the scanning habitable environments with Raman and luminescence for organics and chemical instrument. The carbon-containing molecules were not only found in the interiors of abraded rocks which SHERLOC analysed, but also in the dust on non-abraded rocks as well. Mind you, confirmation of organics is not confirmation that life once existed in Jezero Crater. There are lots of both biological and non-biological mechanisms that create organics. Perseverance's sister rover Curiosity has also discovered organics at its landing site in Gale Crater. But what SHERLOC adds to the story is the ability to map the spatial distribution of the organics inside the rocks and relate those organics to the minerals found there. And that helps scientists understand the environment in which the organics formed. But the preservation of organics inside ancient rocks, regardless of their origin, both at Gale and Jezero craters, does mean that potential biosignatures, that is signs of life, whether past or present, could also be preserved. But that's a question which may not be resolved until the samples are finally returned to Earth in the 2030s. Along with its rock core drilling capabilities, Perseverance has also brought the first ground-penetrating radar to the surface of Mars. RIMFAX, the radar imager for Mars subsurface experiment, creates a, well, I guess you'd call it a radargram of subsurface features up to about 10 metres deep. Data for the first radargram was collected as the rover drove across a ridgeline from the crater floor fractured rough geologic unit onto the Séítah geologic unit. Scientists found the ridgeline contains multiple rock formations with a visible downward tilt. With RIMFAX data, Perseverance scientists now know that these angled rock layers continue at the same angle well below the surface. The radargram also shows that the Séítah rock layers project below those of the crater floor fractured rough. The results further confirm the science team's belief that the creation of Séítah predated the crater floor fractured rough. This ability to observe geologic features even below the surface adds a new dimension to the team's geologic mapping capabilities on Mars. This is SpaceTime. Still to come, NASA's Mars InSight lander forced into safe mode, and exploring the frozen wastes of the Martian North Pole. All that and more still to come on SpaceTime. NASA's Mars InSight lander has been placed into safe mode as a regional dust storm blankets the area. Initial reports suggest the spacecraft is stable and it's sending health data to mission managers. But the dust storm has reduced the level of sunlight reaching the lander's solar array. By placing InSight into a safe mode, power requirements are reduced to essential functions only. So far, there's no indication of the reduced power output affecting the lander's batteries. SpaceTime listeners will remember that it was drained batteries during a global dust storm on the Red Planet, which finally ended operations for NASA's Intrepid Mars Opportunity rover in 2018. Dust blanketing the solar arrays has been a growing problem for InSight in recent times, reducing the lander's power supply. Dust storms can affect solar panels in two ways. Firstly, it physically reduces the amount of sunlight filtering through the atmosphere. And secondly, the dust accumulates on the solar panel's surface. The current dust storm was first detected by NASA's Mars Reconnaissance Orbiter spacecraft, which creates daily colour maps of the entire planet. Those maps allowed scientists to monitor the dust storm's progress and serves as an early warning system for spacecraft on the Martian surface. Sometimes whirlwinds and gusts of stormy weather can even blow dust off the panels over time. And that happened with both Opportunity and its twin Spirit rover, at least for a little while. InSight landed on Mars in 2018 to study the red planet's internal structure. It achieved its primary science objectives a year ago and is now on an extended 2-year mission. This is SpaceTime. Still to come, exploring the frozen wastes of the Martian North Pole. And SpaceX conducts its first launch for 2022. All that and more still to come on SpaceTime. Now, sticking with our Mars theme this evening, astronomers have discovered that formations found across the Martian North Pole known as megaripples migrate across the red planet's frozen surface, together with smaller ripples and larger sand dunes. Megaripples are ridges created over eons by Martian sands, ice and wind. The megaripples on Mars are about 1 to 2 metres tall and have about 5 to 40 metre spacings between them. That places them between sand ripples, which are about 40 centimetres tall, with 1 to 5 metre spacings, and sand dunes, which can be hundreds of metres high, and spacings of between 100 and 300 metres between them. The thing is, megaripples were thought to be largely inactive relics of past climates until now. But new measurements, based on 13 years of observations by the HiRISE instrument aboard NASA's Mars Reconnaissance Orbiter spacecraft, have now changed that view. Scientists found that these mega ripples were migrating across the red planet's surface at an average speed of 0.13 meters per Earth year. Now that's still slow compared to the nearby ripples, which were moving at rates of around 9.6 meters per year, and that's in just 22 days over the Martian northern summer. But it's still dynamic activity, at least on geologic scales. The findings, reported in the journal Geophysical Research Planets, show widespread mega ripple activity across the vast expanse of the northern polar dunes. The authors mapped the mega ripples and the adjacent bedforms across the northern polar sea sands, the most expansive collection of dune fields on Mars, stretching across vast areas of the planet's northern hemisphere. The study's lead author, Matthew Shirzaki from the Planetary Science Institute, says the data shows that the thin Martian atmosphere can mobilize coarse-grained mega ripples, and that overturns prior notions that these were actually static relic landforms from a past climate. Part of the uncertainty in studying the red planet's polar landforms is the long, cold polar winter that eventually covers the region in frozen carbon dioxide and water ice. For wind-driven bedforms such as mega ripples, it means they're unable to migrate for nearly half a year. However, it now appears that the late spring and summer winds that descend off the polar ice cap more than make up for these other periods of inactivity. Mega ripples were found to be widespread across the region, and they were migrating at relatively high rates compared to other sites on Mars at lower latitudes. This enhanced activity is likely related to the greater sand fluxes found in neighbouring dunes, which are driven by summertime seasonal winds when the polar ice is sublimating. The discovery supports the idea that much of the Martian surface is actively being modified and not just some ancient or static relic. Still, there are other mega ripples there which do appear to have stabilised, a likely result of intergranular ice within low wind areas. This report from the Planetary Science Institute.
The landscape of Mars is anything but quiet. Winds do their best to howl in the low-pressure atmosphere, and in their bluster pick up dust and transport it around the red planet. And in some areas of Mars, it isn't just the dust that is carried away by the wind. In the North Polar sand seas, the dunes ripple across the landscape at speeds reaching upwards of half a meter a month. These dunes and other bedforms aren't all the same, however. They vary in size and the spacing of their peaks, and these variations affect the creep of even the largest sand grains across the landscape. The smallest features, simply called ripples, move at the highest speed. These roughly foot-high forms are spaced approximately 3 to 15 feet apart and race through summer before the freezing ice of winter locks them in place. These ripples are tiny next to the massive dunes that can soar hundreds of meters in height and allow space for football fields to rest between their crests. The dunes are largely locked in place as fossils of an early time when Mars had a thicker atmosphere. Intermediate to these structures is the megaripple. Sandy formations that stand as tall as a human, with a spacing of 1 to 5 meters between crests. Since they were first observed, researchers had thought these larger structures were also frozen in place, but when researchers looked long enough, they uncovered a very different reality.
Using repeat HiRISE images acquired over long durations, up to 13 Earth years, we examined the dynamic activity of polar landscapes. We found that the thin Martian atmosphere can mobilize some coarse-grained megaripples, overturning prior notions that these were relic landforms from a past climate. We mapped megaripples in adjacent regions across the North Polar Sand Sea, the most expansive collection of dune fields on Mars.
Just like on Earth, large variations in weather are seen between Mars' equatorial regions and polar regions, and these weather patterns shape the geology. While the equator doesn't see too serious of a seasonal variation, the differences at the poles are extreme to the point that the atmosphere freezes to snow come winter. Come summer, winds rush into the polar regions as the ices sublimate back into gas.
Megaripples were found to be widespread across the region and migrating at relatively high rates relative to other sites on Mars that are at lower latitudes. This enhanced activity is likely related to the greater sand fluxes found for neighboring sand dunes, which are driven by summertime seasonal winds when polar ice is sublimating. This supports the notion that much of the Martian surface is actively being modified and not just ancient or static.
Here on Earth, moving dunes can eat away at human-made structures, covering up roads or burying parts of towns, while also revealing ancient features, and even meteorites as what once was buried becomes revealed. The same is true on Mars.
Sand movement on Mars is responsible for erosion of some materials, but also can re-expose older surfaces that were once buried.
If you want to see the past revealed anew, these ripples and mega ripples are good places to look.
This is SpaceTime. Still to come, SpaceX launched their first rocket for the year, and later in the science report, they've been around for a while now, so it's time to track the effectiveness of COVID-19 vaccines. All that and more still to come on SpaceTime. SpaceX's first launch for 2022 has kicked off lots of excitement in Sydney, with locals reporting UFO sightings after seeing the train of Starlink satellites deployed by the mission. The launch aboard a Falcon 9 rocket from Pad 39A at the Kennedy Space Center in Florida carried 49 of the 260-kilogram satellites on the first of 5 planned missions by SpaceX this month. The flight's trajectory was more southerly than previous SpaceX launches, heading along the Florida coastline towards Miami on a polar orbit in order to provide better recovery weather for the first stage booster and fairings.
The range is green for launch.
Falcon 9's in startup.
Falcon 9's autonomous internal flight computers have now taken over the launch countdown, just awaiting the final go from the launch director.
LD, go for launch.
Let's listen into the terminal count as Falcon 9 takes our 49 Starlink satellites into a 53-degree south inclination orbit.
T-minus 5, 4, 3, 2, 1, liftoff.
T plus 45 seconds into liftoff, and Falcon 9 has successfully lifted off from Launch Complex 39A at Kennedy Space Center, carrying our stack of 49 Starlink satellites to low Earth orbit. Now, moments ago, we did throttle down the engines in preparation for Max Q.
Supersonic.
And that is maximum aerodynamic pressure.
Max Q.
And there's the call out that we just passed through Max Q. That is the largest structural load that the vehicle will see throughout ascent. Now coming up, we will have 3 events happening in quick succession. That'll be main engine cutoff, or what we call MECO, stage separation, and second stage engine start 1, or SES1. MECO is where all 9 of the M1D engines shut off and slow the vehicle down in preparation for stage separation. And
Vac engine chill has started.
And that's just a call out that the engine chill on the second stage is getting ready for ignition. Stage separation is where the first stage separates from the second stage, and with first stage returning back to Earth for landing, while stage 2 continues on its journey with the third event, SES1, or second stage engine start 1. And that's where the MVAC engine ignites up and propels the second stage along with the Starlink satellites to their targeted drop-off orbit. We're just about 10 seconds or so away from those 3 events, and they will be followed by fairing deploy shortly after SES1 as well.
MECO.
Stage separation confirmed.
MVAC ignition.
Fairing separation confirmed.
Now, the fairing halves flying on today's mission are both flight proven, with one half supporting its 5th flight and the other supporting its 4th flight on today's mission. So we will be attempting to recover the halves again using our recovery vessel Doug to hopefully support future missions. The first stage, the grid fins have deployed. Those help guide the vehicle back to its landing zone. Stage 1 will execute 2 burns in order to make its way back to Earth. The first is the entry burn, where 3 of the M1D engines will reignite, and this helps to slow the stage down as it re-enters the upper part of the Earth's atmosphere. Then the second burn is the landing burn. This is the single engine burn that brings the vehicle speed down very rapidly in order to touch down on our drone ship, a shortfall of gravitas today.
Acquisition of signal, Bermuda.
And that's just a call out that we have connected with a ground station on the second stage. Got a nominal trajectory call out on second stage, which is great news.
Stage 1 FTS is saved.
Stage 1 entry burn startup.
The entry burn has begun on that first stage. This will last about 20 seconds or so long.
Stage 1 entry burn shutdown.
Stage 2 FTS is saved.
A shortfall of gravitas waiting for this booster in the Atlantic Ocean. So we are going to have landing burn coming up on first stage. That will last about 20 seconds long. And right when landing burn ends, we should have SECO 1 or second engine cutoff 1 on second stage.
Stage 1 landing burn startup.
There's that call out that the landing burn has begun on first stage.
One
the drone
landing
ship.
leg deploy.
And we have touchdown of Falcon 9. And through the cheering, we also heard that call out for SECO 1, which is great news. Our booster landing today marks our 101st overall successful recovery of a first stage. And 134th successful flight of a Falcon 9 first stage. We also heard nominal orbital insertion for stage 2. Next up will be payload deploy of our 49 Starlink satellites. Today's launch marks the first East Coast launch to a 53-degree south inclination. We're flying in the south degree trajectory to increase recovery weather availability for both the booster and fairing halves during the winter months.
This mission brings to 1,993 the number of Starlink satellites launched by SpaceX so far. Ultimately, the company plans to have at least 30,000 Starlinks in orbit, a project thought to be a hazard to navigation and an unneeded difficulty for astronomical scientific research. This is SpaceTime. And time now to take another brief look at some of the other stories making news in science this week with the Science Report. Scientists have now been able to track more than 9 months of data regarding the effectiveness of COVID-19 vaccines. A report in the New England Journal of Medicine finds that the mRNA vaccines by Pfizer and Moderna protect against COVID-19 infection with 94.5% and 95.9% effectiveness respectively after 2 months, before dropping to 66.6% for Pfizer and 80.3% for Moderna at 7 months. The authors use North Carolina COVID-19 surveillance data to estimate vaccine outcomes for some 10 million people from December 2020 to September 2021. They also found the emergence of the Delta strain in mid-2021 accounted for part of the waning effectiveness of the vaccines, with the Pfizer's effectiveness dropping 15% and Moderna's by 10% as the variant took over. Scientists also found that immunity after the second COVID-19 jab seemed to wane slightly after 20 weeks following the jab, especially for those over 65. The authors looked at protection against hospitalization and death over time following the second dose of both Pfizer and AstraZeneca. The effectiveness against symptomatic COVID-19 caused by the Delta variant seemed to peak in the early weeks after the second dose, and then at 20 weeks decreased to 44.3% for AstraZeneca and 66.3% for Pfizer. Protection against hospitalization decreased only slightly to 80% with AstraZeneca and 91% with Pfizer, while protection against death fell to 84.5% for AstraZeneca and 91.9% for Pfizer. More than 5.5 million people have now been killed by the COVID-19 coronavirus since it first spread out of Wuhan, China. However, the World Health Organization says the true death toll is likely to be double that amount, with more than 315 million confirmed cases worldwide. A new study warns that men who spend a significant portion of their middle age living alone or experiencing multiple breakups could be at higher risk of inflammation. The findings, reported in the Journal of Epidemiology and Community Health, looked at a Danish cohort of some 5,000 adults aged between 48 and 62. The authors looked at how long they lived alone, how many breakups they experienced during that time, and inflammatory markers in their blood, which are an indicator for a higher risk of age-related ill health. They found that men who had the most breakups had the highest level of inflammatory markers, followed by men who lived alone for at least 7 years. Scientists also noted that none of these associations were found in women, which could be influenced by gendered behaviours in response to a breakup in middle age. Swiss researchers have developed a new way to measure whether or not you go off to your final reward feeling like you've lived a fulfilled life. Scientists created a test of fulfillment based on 9 different elements, including realizing your full potential, feeling true to yourself, feeling that your existence is significant, that you've left a unique mark on the world, and that you've contributed to the well-being of others. The findings, reported in the Journal of Frontiers of Psychology, show that a fulfilled life is not a self-centered life. The authors found that making an impact and leaving a positive mark in others' lives is viewed by people as an essential component of a fulfilled life. They say performing meaningful activities, engaging in tasks which make you feel absorbed, or pursuing goals from which you get a sense of achievement all make living a fulfilled life more likely. A group of creationists claim they've discovered the site of Noah's Ark in Turkey near the Iranian border. The team say they've created a 3-dimensional scan of a boat-shaped formation on Mount Tenderach, which matches Noah's Ark's dimensions as reported in the book of Genesis in the Jewish Bible or Old Testament. Now, creationists first pointed at this particular rock formation back in 1959, and they've kept pointing at it ever since. That's despite repeated scientific evidence that it is just a geologic rock formation, nothing more. But the group won't be put off. They have faith, claiming their new scans show parallel lines and angular shapes below the ground, which could be rooms or pens underneath a deck or platform. But there's another problem with the location of the rock formation come arc, and that's the fact that it's on the slopes of a volcanic mountain which shows signs of recent eruptions that occurred after the time of the biblical flood. So, is the site really the mountains of Ararat described in the Bible? And are these rocks really the petrified remains of Noah's Ark? Tim Mendham from Australian Skeptics says even fellow creationists are disputing the claim.
This is a site on a mountain in Turkey, not Mount Ararat, which is actually 2 mountains, by the way, but on a different mountain in Turkey, there's this geological formation that looks a bit like a boat or a ship. It's got pointy ends on it and it's sort of longish, so it's a slice of orange.
Is this the one we see in all the documentary films?
It is these days, yeah, and it's been around and been claimed to have been, the resting place of Noah's Ark for at least about 50 years, if not more. That people have been claiming this. No indication at all that it's anything more than a geological formation. But this recent bunch did 3D scans. Well, of course, therefore that's proof, isn't it? It makes sense, 3D scans. I'm not quite sure how deep a 3D scan can go down into a geological formation, but they said this proved this was Noah's Ark. But as always with the creationist movement, there's a lot of intramural, is that the word? Argument, etc., internal disputes between creationism groups, etc. And in fact, that the group in Australia split because of differences of opinion, and half of them went to America. And those ones who are in America are the ones who are now discounting this new discovery. The one who set up the Creation Museum in whatever place it is in the US with a life-size model of the Ark, his own version, but he said that, no, we've known about this one for ages. It's not Noah's Ark. It's been debunked. And another Australian creationist in the US pointed out that there wouldn't be anything left over of Noah's Ark anyway, because there wouldn't be any trees left after the flood, so they'd have to dismantle the Ark just to build their houses and do their barbecues and things.
The idea of a great flood is not new, and in fact, if you have a look at the history of the Black Sea area, there was originally a freshwater lake there, and then the Mediterranean overflowed the Bosphorus and formed the Black Sea as we have today. So the idea of a real historical background for the flood story isn't hard to believe. The idea of 2x2 animals going up into a boat and the lions not eating the zebras, that's a bit more difficult.
Yeah, I mean, but you've had a long time to actually sort of work out the logistics of a boat. But yeah, the Epic of Gilgamesh talks about, which is Babylonian myth well before. When you're talking about the Tigris and Euphrates area, the Fertile Crescent, those areas are fertile because they flood, right, between the two rivers. And the Epic of Gilgamesh talks about a flood, and of course that being a Babylonian myth, and the Jews being, a lot of Jews being imprisoned in Babylon and then leaving Babylon would have probably picked up on this myth anyway. But yeah, there's a similar flood myth in ancient Greek philosophy, ancient Greek mythology, which is very similar to actually the Noah's Ark, where they do collect animals in these things. Obviously, it makes sense if you want to keep all the animals alive.
Keep your farm animals safe.
That's right, yeah. So, I mean, yeah, there are flood myths all over the place because floods happen, and they don't tend to happen on a global scale. But there might be a local flood, and therefore, seeing as the local area is the only area you know, it becomes a global flood. But, the Noah's Ark bit is perhaps a bit more sophisticated than some, but they have had a long time to work on it, even back then when the original books of the Bible were being written. Whether it was written by Moses or not is a different story. But you look at Genesis, all those stories in Genesis, they've had a long time to gestate and try and take out some of the errors, although by no means all of them.
That's Tim Mendham from Australian Skeptics. That's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more SpaceTime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.